Hi guys, in this video we are going to continue with the Harvard mathematics problems, and we are going to be looking at exercise 3 and the second part. So probably if you are a Harvard University student, you find out that I have skipped the first part, and it is for a reason. I'm going to do that in another video. So it's just that the two topics are not really related, so I prefer to do each topic in a video. So the question reads: consider a 2-pi periodic function defined by f of x is equal to x. The first part is asking us to sketch the graph of f on the interval negative pi to pi. The second is asking us to prove that f is an odd function. And lastly, we are to find the Fourier coefficients a0, an and bn of the function f. So pay kind attention to the solution. If you have not watched the solution to exercise 4, the complete solution to exercise 4 and exercise 2 second part, I'm going to include the link to those videos in the description, so make sure you check it out. Okay, so let's go straight away to solving this problem. We're being told that f of x is a 2-pi periodic function. It simply means that f of x plus or minus 2-pi is the same as f of x. Now the first part of the equation is asking us to sketch the graph of f on the interval negative pi to pi. So I'm just going to indicate some various values. We know that f of x is equal to x. So our table, we have values of x. Our x ranges from negative pi to pi. So within, I can fit some values, arbitrary values, maybe negative pi on 2, 0 and pi on 2. Now since f of x is equal to x, it simply means that when x is negative pi, you also get negative pi there, you get negative pi on 2 there, you get 0 there, you get pi on 2, and you get pi. Now sketching it, we have our coordinate axis, which is our f of x and our x. Now we begin with a point x equal to negative pi. Our f of x is negative pi as well, so that is the point, negative pi, negative pi. Next we go to 0. Both of them are 0, so we have 0, 0, and next we go to pi. Both of them are pi, so we get pi, pi. Now let's plot negative pi on 2. So x equal to negative pi on 2, f of x is negative pi on 2, so that's the point. X equal to positive pi on 2, f of x equal to positive pi on 2, so that is a point. So that is a line by linking all those points together. So it ranges from negative pi right up to pi, and that is a sketch of our function in the interval negative pi to pi. Now the second part of the equation is asking us to prove that f is an odd function. Now all we are required to show is that f of negative x is equal to negative f of x as per the definition of an odd function. So f of x equal to x, it means that f of negative x is equal to negative f of negative x is equal to negative x, therefore meaning that f of negative x is negative f of x, because f of x is simply x, hence f is an odd function, and that is all. Now the last part is asking us to find the Fourier coefficients a0, an and bn of my function f. Okay, so if f is continuous on a certain interval negative ll, then we can define the Fourier coefficients a0 as 1 over l, the integral from negative l to l of f of x dx, an as 1 over l, the integral from negative l to l of f of x times the cosine of n pi x on l dx, and the bn to be 1 over l, the integral from negative l to l of f of x times the sine of n pi x divided by l dx. Now n pi x all over l is simply n pi x all over pi, simply because if we compare the general case, which is f of x is a continuous function in this interval, then we can clearly see that it is equivalent to this interval, so l is equal to pi, so that's why we replace pi there, and therefore we get n pi x on pi to be equal to nx and not n pi, so we should take care, here is supposed to be nx. Okay, so with that we can now proceed to finding these Fourier coefficients individually. So let's begin with a0. It's simply 1 over pi, since l is pi, the integral from negative pi to pi of f of x dx. So we have 1 over pi, the integral from negative pi to pi of x dx. But my f of x is an odd function, and by the definition of being an odd function, it means that the integral from negative pi to pi of my f of x is 0. So from there we get 1 over pi times 0, which is 0. Now the next Fourier coefficient is an, which is the integral, which is 1 over n, the integral from negative pi to pi of cosine of nx, because we have n pi x on L to be equal to nx, as we have seen. So from there we can use either integration by parts, because you know this f of x is actually equal to x, so we can use integration by parts, or we use the definition. Now it is shorter to use a definition than to use integration by parts. Now what is the definition? If f is an odd function, then our Fourier coefficients a of n and a of 0 are both 0. So by saying that, it means our an here is equal to 0. But let's see why it is true. So if I let g of x to be equal to x times the cosine of nx, our x is simply f of x. Then we can look for g of negative x. We get negative x times the cosine of negative x. But the cosine function is an even function, so the cosine of negative nx is the same as the cosine of nx. So it means our g of x simply be g of negative x is negative x times the cosine of nx, and x times the cosine of nx is g of x. So multiply by the negative, we get g of negative x to be equal to negative g of x. Hence g of x is an odd function, and by the definition, the integral from negative pi to pi will give us 0. So this integral is going to give us 0 times 1 over pi will still give us 0. So our an is equal to 0. Now our bn is the integral, that is 1 over pi, the integral from negative pi to pi of f of x times the sine of nx. Generally it is n pi x on L, but L is pi, so we get nx. So from there we can replace our f of x with x, and we get 1 over pi, the integral from negative pi to pi of x times the sine of nx dx. Now this is generally an odd function, but anyways we are going to use integration by parts here, because sine of nx is an odd function, and our x here is also an odd function, so the product will give us an even function. So the integral cannot give us 0. The integral is simply going to give us 2 times the integral now from 0 to pi, but we are going to see that. So using integration by parts, we let u to be x, it means du is equal to dx. We let dv to be sine nx dx, meaning that v, integrating both sides, integrating sine of nx, we get negative 1 on n, the cosine of nx. Now it means that my b of n is simply 2 on n. Now the integral from 0 to pi, actually, because we have identified this as an even function. So using the integration by part formula, you have uv now from 0 to pi, because I have multiplied everything here by 2 times the integral from 0 to pi of v du. Now fitting it, the respective terms into their places, we get b of n to be our 2 of pi remains. Now our u is x, and then our v is negative 1 on n times the cosine of nx. Now the limits of integration are from 0 to pi, plus it is actually minus, but now since we have v here, which is negative 1 on n, it becomes plus, then times now the cosine of nx. So we integrate each. This one here, we can fit the upper bound of x. Fitting the upper bound of x here, we get the place of x, we put pi, we get negative pi on n, the cosine of pi n, replacing x here. Fitting the lower bound, which is 0, we get 0, so it annuls. Secondly, integrating the cosine of 1 on n, we get 1 on n, the sine, the cosine of 1 on nx, we get 1 on n, the sine of nx. So the 1 on n multiplies with this to give us 1 on n squared times the sine of nx, and the limits are from 0 to pi. So fitting the upper limit, which is pi, we get 0, because the sine of pi n is 0, and fitting 0 we get 0. So finally we get our bn to be 2 on pi times now the cosine of pi n is negative 1 raised to the power n, but now there is also a negative 1 here, so you have negative 1 times negative 1 raised to the power n, which gives us negative 1 raised to the power n plus 1, then times the pi here, then all of that divided by n. So you see this pi here is going to cancel with this pi here, and we conclude that our b of n is 2 on n times negative 1 raised to the power n plus 1. So those are the Fourier coefficients: a0, which is 0, an, which is 0 as well, and then bn, which is 2 on n times negative 1 raised to the power n plus 1. So that was that for the video.